Hey guys, today we're going to get into our next unit, which is rational expressions. Sorry, it's Unit 8, rational expressions, and we're going to start with simplifying our radicals. So let's look at what actually a radical is. So if we look at the radical that I've given you here, this is your radical sign. Some of you may know it as the square root sign, but you have to keep in mind it is not always going to be the square root sign. It depends on what the number here is, your index. It depends on what your index is, whether it's going to be a square root, a cube root, or another type of root. So this number out here is your index. When you're given a square root, like the square root of 9, notice you don't see an index here. The square root will never have the index. Anything higher will have the index to show that you are finding a cube root or some other root. So the square root of 9, what number times itself gives me 9? And that would be 3. So 9 is a perfect square. All right, A, number under your radical sign, that is called your radicand. Now we're going to need to list our perfect squares because in order to simplify radicals, we are going to need to know our perfect squares up to about probably 12. We probably should have those memorized to help us. So what is my first perfect square? 1 is your first perfect square. The square root of 1 is 1. So if I start with the number 1, 1 squared equals 1. Go to the next number. Start with 2. 2 squared is 4. 4 is a perfect square. So these bottom ones, these bottom lists are perfect squares, but I'm showing you where I get them from. The square root of 4 is 2. The next perfect square, every number has a perfect square. So after the number 2 comes the number 3. 3 squared is 9. 9 is your perfect square. The square root of 9 is 3. You all see where I'm going with this? Just keep going. The next number after 3 is 4. 4 squared is 16. That's your next perfect square. Square root of 16 is 4. 5 squared is 25. 25 is the perfect square. Square root of 25 is 5. I'm just going to keep listing your perfect. So far, our perfect squares are 1, 4, 9, 16, 25. After that, it'll be 6. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. So that is where I am getting my perfect squares. These are all my perfect squares. And I'm going to need to know my perfect squares in order to reduce my radicals. Right, in order to simplify a square root that isn't a perfect square, we have to find two numbers that multiply together to equal the number under the radical, or the radicand. And one of those numbers needs to be a perfect square. So if I look at the square root of 20, what are some of the multiples of 20? Write down your multiples. I got 1 times 20, 2 times 10, 4 times 5. Out of all those choices, which pair contains a perfect square? Very good. This last one has a perfect square. 4 is a perfect square. So I rewrite radical 20 as radical 4 times radical 5. Each one of those, each radicand gets put under a radical. So the square root of 20 is the square root of 4 times the square root of 5. Then simplify the radicals if you can. What is the square root of 4? Well, it's 2, and I lose the radical sign because it's a perfect square. Do I know the square root of 5? I don't know the square root of 5. And is it a perfect square? No, it is not a perfect square, so I leave it. So my answer is 2 radical 5. If I were to go check myself on the calculator, if I put in the square root of 20, I get some crazy decimal. And now put in my answer so I can check myself. 2 radical 5. And I get yet notice I get the same exact thing. So if this were multiple choice, I wouldn't even really need to sit here and break it all down like I did. I could just put my question in, put my multiple choice options in, and then see which ones match up. Alright, let's try one on our own. Alright, square root of 24. 24 is not a perfect square. There is no number times itself that's going to give me 24. So, we need to write down all the multiples of 24 and see which one has a perfect square. A 1 and 24, 2 and 12, 8 and 3, 6 and 4. Am I missing any there? I think those seem to be all the multiples of 24. Now, look to see, step 2, out of all those choices, which pair contains a perfect square? Very good. This is your perfect square. So 24 breaks into radical 6 times radical 4. Or, I usually like to put the perfect square first, so 4 times 6. Does it matter? No. No, give each one of those radicands, each number under the radical, give it its own radical here. And then take the square root of the one that you can. So the square root of 4 is 2, you can use your radical sign. The square root of 6, I don't know the square root of 6, and it's not a perfect square, so leave it. So radical 24 equals 2 radical 6. Go check myself on the calculator. The square root of 24 is that decimal, and then do 2 radical 6 and see if it gets the same, and it does. Let's go practice a couple more on our own and see where we can get with it. The square root of 12. 12 is not a perfect square. So what number times itself is going to give me 12? What are the main perfect squares? The multiples of 12. 1 and 12, 6 and 2, what else? 3 and 4? Out of that list, which one is perfect square? The last one. So the square root of 12. I just break it up right away into its own radical. Radical 4 times radical 3. The square root of 4 is 2. I lose my radical there. And the square root of 3, just leave it. And that's my answer. I could go ahead and check myself to make sure. Notice on this next question, I have a number in front of my radical. Make sure you leave that number in front of it and still break down 18. What are the multiples? 18 and 1, 6 and 3, 9 and 2. Which one of those is a perfect square? And it is our last one. So put each one under a radical. So now I have the 5 up front, 5 times radical 9 times radical 2. Leave your 5. Since it's all being multiplied, I'm showing my little multiplication sign there. The square root of 9 is 3. I'll lose the radical and leave radical 2 because it's not a perfect square and I can't break it down anymore. Then I can go ahead and multiply my numbers up front. So 5 times 3 is 15, radical 2. I can check myself. Let's go check on the calculator. 5, radical 18. That gives me that decimal. Then 15, radical 2. It gives me the same decimal, so you should never get any of these wrong, so you can always check yourself. The square root of 21. Well, what are the multiples? 21 times 2, 7 times 3. Is there anything else that gives me 21? There isn't. Are either one of these, any of these numbers a perfect square? They are not. So can I simplify this anymore? No, cannot be simplified. Let's jump on to the next one. I'm going to skip those two. I'm going to go to number 6. So the square root of 200. I always think about what are the multiples. 201, 50 and 4, and 102. Anything else that we can think? There's not much else that I can think of there, so let's see what we get here. Notice, this has a set of a perfect square, and this has a perfect square. Is it 4 a perfect square and 100 a perfect square? Take the biggest perfect square. So I would use this set. So it breaks down into the square root of 100 100 and the square root of 2. Well, what is the square root of 100? It's 10, and I lose the radical sign because it's a perfect square. The square root of 2, I don't know it, so I just leave it. And I am done. If I were to do this one, I'm not wrong, I would just have to go further. So I'm going to show you how you can do that one also. So it breaks down to the square root of 4 and the square root of 50. The square root of 4 is 2. The square root of 50, it's not a perfect square, but can it be broken down further? And it can. Think of the multiples of 50. 50 and 1, 25 and 2, 10 and 5. Which one of those has a perfect square? And it's that one right here. So I would have to, in this situation, I would just have to make sure I break down 50 further, which is fine. I'm going to get the same answer. I'm just going to have to do a little more work. So 50 breaks down into 25 and 2. Leave this 2. The square root of 25 is 5. I'll lose the radical because it's a perfect square. The square root of 2, do I know what it is? There isn't one. Can I break it down? No, so leave it. So if I go ahead and multiply the numbers up front, I get 10 radical 2. Same answer that I did before, I just had to do a little bit more work. So no big deal, just make sure you keep breaking it down as far as you possibly can. Alright, so of course it's not going to stay that easy, it's going to go further. We really need to worry about simplifying radicals with variables. So what we previously did, kind of a review, we've looked at that before, now we need to worry about the variable part. So, the square root of 16 means what was multiplied by itself to equal 16? What number times itself gave me 16? Well, that number was 4. So that is where I got the square root of 16 is 4. Using the same idea, what is the square root of x squared? What times itself gave me x squared? So think about that. When I'm multiplying with variables, what do I do with the exponents? And you are correct, you add. So if I had x times x to the first times x to the first, keep the base and add the exponents. So what would the square root of x squared be? It would be x1, or just x. What about the square root of m to the 4? What variable with an exponent times itself would give you the 4? What would that be? M times n. What would the variable have to be here to give me a 4? Remember, when you're multiplying like bases, you keep the base and you add the exponent. So what would the exponent have to be to give me a 4 there? It would have to be a 2 and a 2. Remember, you're looking for what thing, because some people would try to tell me 3 and 1. Yes, that adds to 4, but you want that variable times itself to give you what's under the radical. So Z6, well, what would that be? What would the variable? The variable has to be, the exponent has to be the same. So that would be Z3. And this would be C10. Notice what you're doing. What did you do to this 2 to get the 1? What did you do to this 4 to get the 2? What did you do to this 6 to get the 3? What did you do to that 20 to get the 10? And you are correct. You are taking half of each one of those numbers. So list the perfect squares that contain variables. The very first one is x squared. And the square root of that would be x. The next perfect square with the variable is x4. The square root of that would be x2. x6, and the square root of that would be x3. Notice, the exponents 1 here, 1, 2, 3. Each one has a perfect square. So x8 would be x4. The square root of x10 would be x5. So all these in the top are my perfect squares with variables. x12 would be x6. The square root of x to the 14th would be x7. The square root of x to the 16th would be x8. Square root of x to the 18th would be x9. You get the hint here. So the top row is all my perfect squares with variables. And I think I just asked this question. What do you notice about all of these terms? You notice that we said all the exponents are cut in half when you're finding the perfect square. But what do you notice about all the perfect square ones, these top ones? What do you notice about those numbers? Those exponents there. All those exponents are even numbers. So all exponents are even numbers. Keep that in mind. Alright, let's simplify 16, square root of 16 and 10. Work with the numbers separately from the variables. So I'm going to go ahead and show you. In this case, 16 is a perfect square and m10 is a perfect square. Bring each one of them into their own radical. That helps you work it out. Since they're both perfect squares, take the square root of both terms. So the square root of 16 is 4. The square root of m to the 10 is m to the 5th. You lose the radical on both of them, but they're both perfect squares. And that is where we got my answer of 4m to the 5th. Alright, let's go ahead and do another example. Work with the numbers separately from the variables. x6 is a perfect square, but 8 is not. So the square root of 8 will need to be simplified. So break it apart. Each one gets its own radical. Notice what I did here. The square root of 8, since it's not a perfect square, ask yourself, what two numbers multiplied by itself gives me 8? One of them has to be a perfect square. So what are the multiples? 8 and 1 and 4 and 2. Those are the only ones. So this one has a perfect square, which is where they got radical 4 times radical 2. The square root of this right here would be x3. Half of 6 is 3. So finish this. The square root of 4 is 2. I lose my radical. The square root of 2. It's not a perfect square, and I can't break it down any further, so leave it. And I already took the square root of this one, so I leave my answer. The radical comes last. Everything else comes before it. So 2x3, leave the radical 2 on the end. And that is where they got their answer. Alright, so this very last one that I set up for you, and then we'll do some together. So if you notice 27b7, work with the numbers separately from the variables. Neither 27 nor b to the 7 are perfect squares. So both will need to be simplified by using the perfect square list. Give each part its own radical. So before I get to this chunk, I'm going to show you, give each part its own radical. Radical 27, radical b7. Now ask yourself, how did they get here? How did they get here? Let me explain that before they jump to that. This is not a perfect square. So what are the multiples of 27? One of them has to be a perfect square. 27 and 1, 9 and 3. I believe those are the only ones. Well, this one has the perfect square, so break it down. Square root of 9 times the square root of 3. I'm going to finish this list right here before I go to the variable. So the square root of 9 is 3. The square root of 3, I don't know what it is and I can't go any further, so I'm going to leave it. B to the 7. Is there any number? Think about this. V times V. What exponent has to be the same exponent, adds together to give me 7? Well, there isn't one. Notice that's an odd number. When that occurs, it's not a perfect square. So go ahead, take 1 away from this, and break it down into V6 and V1. Because V6 and V1 gives me V7, and one of them is a perfect square for a variable. So just like I did over here, I found the multiples, and one of them was a perfect square for my numbers. Over here, I found the multiples, and one of them was a perfect square for my variables. Now go further. The square root of b to the 6. I can take half of 6 evenly. So half of 6 is 3. Lose the radical because it was a perfect square for a variable. Can I take half of 1 and have it be a whole number? No, so leave it as radical z. At the very end, you need to make sure anything that is not under the radical comes first. So 3v3, anything that has a radical goes together under 1 radical. And that is my answer. So when I throw in variables, it is not easy for you to check them like it was before. Let's try some completely on our own. All right, 36 n to the 18. Separate them. 36 gets its radical, and n18 gets its radical. Do you have perfect squares? Is this a perfect square? It is. The square root of 36 is 6. Is this a perfect square for a variable? Remember, if it's a perfect square for a variable, the exponent has to be an even number that I can cut in half and get an even number. And half of 18 is 9, so I lose my radical again. So if I put that together, my answer is just 6 and 9. And I'm done. Let's go to the next one. Notice I have a number in front of my variable. Leave that. I only have, sorry, I said I have a number in front of my variable. This is a number in front of the radical sign. So leave that. Underneath my radical sign, I only have a variable. So let's ask ourselves, is this a perfect square variable? And in my head, I automatically realize this exponent is odd. Is it a perfect square exponent if it's odd? No, it's not. So take 1 away and break it down into z10, because that's a perfect square variable, and z1. Remember, 10 and 1 gives me my 11, and this one is a perfect square. So now see if I can go further. Leave the 2 out front. What is the square root of z to the 10? When it isn't even, I can take half of it and lose the radical. So z to the 5th. If it's an odd, I can't take half of it, and this one I can't break down any further, so leave it as radical z1. If I put this all together, 2z5 times radical z to the 1st, and I'm done. Try this last one, and then I'll let you go ahead and try some other practice on your own. Break each one into its own radical. Look at them separately. The square root of 28, the square root of w to the 17. Now ask yourself, is 28 a perfect square? If it's not, what are the multiples? One of them has to be a perfect square. So 28 and 1. What else? 14 and 2. And what? 7 and 4? Isn't that the only one that has a perfect square? So break it down. Radical 4 times radical 7. I'm going to finish this one first before I go over the variable. The square root of 4 is 2. Do I know the square root of 7? No, because it's not a perfect square. Can I break it down any further? No. So leave it. Now I still have this. The square root of w to the 17. Well, you should realize right away, this is an odd number. It's an odd number. It's not a perfect square for a variable. So subtract 1, make it w to the 16 times w to the 1. Because remember, w to the 16 times w to the 1, you keep the w and you add the exponents when you're multiplying. And now this, because I have an even exponent, this is a perfect square for a variable. So half of 16 is 8. Lose the radical because it's a perfect square variable. Is this a perfect square variable? It is not, so leave it. Remember my rule at the very end. Anything not under the radical goes together and it goes first. Anything under the radical goes together under one radical. Now keep in mind, you don't have to put the 1 here, but you can. You're not wrong either way, because you know if it's not there, you really know it to be there. But if it's there, it's fine too. All right, go ahead and check the little classroom for what you need to do next.